Hi everyone, so we're going to go through matrix type multiple choice questions. I have two questions here for us to look at first. The reason why I have them side by side next to each other because they're both similar. It both involves product of two matrices. I already went ahead and worked out the first one, but I'm going to go through it with you and then we're going to do the second one together, right? So in the first one, we have matrix A, which is 2, 0, 1, negative 1. Then we have matrix B, which is 0, 3, negative 2, 1. Now, first, I would say write down the order of each matrix. So remember, order, we write it as number of rows by the number of columns. So here we have 2 rows, so 2 by 2 columns. 2 by 2 is this matrix. And then here is also same thing, right? 2 rows and 2 columns, so 2 by 2. So in order to know if two matrices can be multiplied, we look at the two inside numbers here. So you see those two inside numbers, they're the same, right? So once the number of columns in the first matrix is equal to the number of rows in the second matrix, you can go ahead and multiply. Now for two 2 by 2 matrices, you should automatically know they can multiply, right? Because they're both the same order, right? But I'm just showing you all just so you could check for different instances like the second one, which we'll have to check, right? Alright, so I just rewrote the two matrices here. Let's start going. Remember to multiply matrices, you can look at one of the videos that I would have done before. But just to recap, it's row by column, right? And I do it for the first row, first column, first row, second column, then second row, first column, second row, second column. So let's go. First row, first column. So we're taking the 2 and multiplying by the first number in the first column. So 2 by 0 plus the second number in the first row by the second number in the first column. So that's 1 by 3. So we recap that. 2 by 0 plus 1 by 3. Now we're going to go first row, second column. So same procedure. First number by the first number in the second column. So 2 by negative 2 plus 1 by 1. Now we're going to go second row, first column. So same procedure, 0 by 0 plus negative 1 by 3. And then second row, second column, 0 by negative 2 plus negative 1 by 1. Now if you look at it carefully, you can tell that once you do the first row, the second number usually repeats. You see how we got the 0 there, the 3 there, the negative 2 basically comes down, and the 1 there, right? That's just something to know, right? A little pattern to know about. Right, so let's simplify. 2 by 0 is 0, 1 by 3 is 3, 2 by negative 2 is negative 4, 1 by 1 is 1. So 0 plus 3, negative 4 plus 1. Then we have 0 by 0 is 0 plus negative 1 by 3 is negative 3. 0 by negative 2 is 0 plus negative 1 by 1 is negative 1. And then let's simplify. 0 plus 3 is 3. Negative 4 plus 1 is negative 3. A plus and a minus gives me a minus. So this is essentially 0 take away 3, which is the take away 3 minus 3. And then we have same thing here, plus and a minus is a minus. So 0 minus 1, which is just minus 1. So my answer is actually A, which I identified up there, right? So now we're looking at the second one here. Let's look at the order of this matrix A and the order of this matrix B there. So in matrix A on the right hand side here, we have 2 rows and 3 columns. So this is a 2 by 3. And for this one, so for this second one, I was saying the order of matrix A, we have 2 rows and 3 columns. And then for the second matrix B, we have 3 rows and 2 columns. Again, see the two numbers inside are the same? So the number of columns in the first matrix is equal to the number of rows in the second matrix. Something to note as well. You see these two outside numbers? they tell you what result we're gonna what is going to be the order of the resultant matrix. So resultant matrix is going to be a 2 by 2, just like the first one here. If we look at the outside numbers, the resultant matrix would be a 2 by 2, and well, the options give it away because all are 2 by 2 as well, right? All right, so let's come across now and start working it out. So let's work it out. Let's write over the matrices. -3, 5, and then 3, 2, 0, 0, 1, 5. Alright, so let's go row by column, row by column. First row by first column. So 1 by 3 plus 3 by 2 plus -3 by 0. Now let's go first row, second column. So 1 by 0 plus 3 by 1 plus -3 by 5. So yes, a lot to write out. Second row now, first column. So 3 by 3. So you see how my numbers are repeating. The 3 comes back down. Plus 0 by 2. Plus 5 by and a 0. And then second row, second column. 3 by 0. Plus 0 by 1 plus 5 by 5. And now it's to simplify. So 1 by 3 is 3 plus 3 by 2 is 6 plus 3 by -3 by 0 is 0, right? And let's come across here. So 1 by 0 is 0 plus 3 by 1. 3 by 1 is 3 plus -3 by 5 is -15. And now 3 by 3 is 9 plus 0 by 2 is 0 plus 5 by 0 is 0. 3 by 0 is 0 plus 0 by 1 is 0 plus 5 by 5 is 25. So we're going to get 3 plus 6 plus 0, that's going to give me 9. And now here, a positive and a negative will give me a negative. So this is really 3 take away 15. So 3 take away 15 is going to give me -12. Remember the 0, when you add or subtract the 0, it's unchanged, right? 9 plus 0 plus 0, that's just 9. And then here we get 25. So let's check and see which one gives us our answer. 9, 9, -12, 25, and that will be A. So the both answers are A. So take your time, pause whenever you need to go over replay, right? So these are the first two types that we're looking at. So now we're looking at these two questions. We're looking at the left-hand side one first. So let's read together. Two matrices, A and B, are conformable for multiplication A by B if... So first of all, we need to understand what that question asking. Some of us might see the word conformable and be like, what? But really and truly what the question is saying or asking is saying that how how do we know that two matrices can be multiplied? And remember, if you look back at the first two questions we just did, I was showing you all that the number of columns in the first matrix must be equal to the number of rows in the second matrix. And this is what B says here. Right? Now, let me just show you an example, right? Or write back the one that we did for the second one here. So let's say 2, 1, 1, 4, 0, 5, and let's say we have 6, 7, 9, 1, 2, 4. The order of this first matrix is a what? 2 rows, 3 columns, 2 by 3. Order of this matrix here is a 3 by 2. 3 rows, 2 columns. Remember I said these two numbers inside they have to be the same. So the number of columns in the first matrix, so we can call this first matrix A. The number of columns in matrix A must be equal to the number of rows in matrix B. So very simple, something to remember, right? Now we're looking at the right hand side, this question here. So we're given matrix X and we're given matrix Y. What is the order of the matrix product XY? So again, I would have shown you this in the first two questions. So first thing, write down the order of matrix X. You have 2 rows and 3 columns. Matrix Y, we have 3 rows and 2 columns. It's a 3 by 2. So yes, the two numbers inside lets us know what if the two matrices could be multiplied. Remember I said the numbers at the outside tells us what would be the order of the resultant matrix. So actually be a 2 by 2, which is A, right? Now, what if you didn't remember this for exams? What you're going to do, right? Well, what you could do is, which I will show you now, 1, 3, 3, 0. You could do it the long way meaning you multiply these two matrices, right? And it actually, this is just like the question, the second question we would have done with the product. So it's actually just that you multiply it out and you get the resultant matrix, and then you realize, hey, this is a 2 by 2 matrix. But what I showed you at the top here, this is the shortest, and it would be the easiest way, it should be the easiest way for you to remember quickly, because working out all of this is going to take up some time, right? So the answer for this one is A. Now, here we have two questions. They're both linked because we have the two matrices at the top. Matrix P and then matrix Q. So matrix Q, what is the order of matrix Q? Simple, remember, order, as I've been saying before, row by column, number of rows by number of columns. How many rows we have? 1, 2, 3, 3 rows. How many columns we have? 1, 2, 3, 4. So it's a 3 by 4 matrix, which is A. And then the second piece, the determinant, we want to find the determinant of P. So P is 8, 7, 6, 5. So again, we did determinant before one of the videos, so you can look back at how to recap to find the determinant, right? So determinant, product of the first diagonal, so the first diagonal is 8 and 5, product is 8 times 5. Product of the first diagonal, take away the product of the second diagonal. The second diagonal is 6 and 7. So the product here is 6 by 7. So 8 by 5 is 40. Take away 6 by 7 is 42. And my determinant is minus 2, which is B. I was trying to draw a little arrow there, but that didn't work out. But yes, the answer is